it's primarily built around the area that, or the idea that a lot of blockchain development requires networking, the database layer, the consensus layer, and all those cross-cutting components which are essential in building any blockchain. And that is where Substrate comes very handy, because it provides you all those components out of the box, and all you need to worry about is your business logic. Is your blockchain logic, which is also called the runtime in the broader sense. So that's what we are going to look at today: how you build your own runtime, because everything else is already taken care by Substrate. So let's look into that. And what I'm going to also dive into is a little bit of tooling that we have built. So one of the major focus from the Substrate team is also to allow the users and the developers use Substrate in a more efficient way. And to do that, we have built a few scripts, some other framework components, some low-level libraries to allow you to do that in a fast way. So I'm going to look into those sides of things as well. What are these tools, how you can use them, and what will be the best way to use them. And around that, how we can then look at a working runtime. So the idea of the talk is basically going over these tools and looking at, and I'll be showing a live demo of runtime. So the first step that comes into when you are doing any development with any framework is how to install it. So we do have a bunch of scripts to get you started on that. The first one basically is, so we have one script here on this slide, which is basically presented in two formats or two variants. First one is the default one, which you will see on our the docs homepage as well, which gives you a full-fledged node or compiled working node on your machine, along with all the dependencies installed. Now, once that script completes, you can simply say Substrate, and there will be a local node running on your system. The second variant, however, is a much faster variant of this same script, because it does not install the binaries and the node on your system. It just gives you the dependencies. So it will install Rust and other framework dependencies that Substrate needs, but it will not install and compile the code on your machine, the second one. So for getting started with the development side of things, especially for when we are building our own runtime, the second one is a more optimal solution to get started and install Substrate on your machine. The first one is more for just trying it out of the box. So once you are basically done with the installation, and it takes a couple of minutes because the first variant is, in itself actually downloads and compiles all the binaries, which are all in Rust. So it takes a few minutes because of the low-level LLVM magic that Rust does while compilation. It takes some time. So once you're done with that, the next thing that you need to do for building a runtime from scratch is basically utilizing a script which also gets installed by that previous script, is creating a node for yourself. I will actually, from this point on, just jump into my laptop and show you step by step how this is done instead of going through the slides. So let me just quickly do that. So on my screen here, we have two scripts. One is basically creating a template node for you, so it brings along all the dependencies, all the framework components which are needed to basically compile and run a node on your machine. So let me show you the output of this particular script, what it does. So on my screen right now, I have a project open inside Visual Studio Code which has a bunch of files on it. Is it visible to everyone, or should I zoom in a little bit? Is it better now? Okay. So this is what the output, or you can say what gets on your machine once you run the Substrate node new script. And how you do that is basically as simple as just calling the Substrate node new. And then the name of your runtime, which whatever you want to say. For example, my runtime that I'm currently showing you is called .a demo, as you can see on the Visual Studio title bar. and you can call it anything, for example, demo2 or something like that. And then optionally, you can also provide the name of the author. For example, in my Runtime, I provided my GitHub username, and you can provide something here as well. So it can be any string, by the way. It doesn't have to be GitHub username, but just for basically demo purposes, we generally do that. So this is how you run this command. When you run this, what it will do is it will create this particular solution structure on your machine. And it also takes a few minutes to do all this because of the LLVM compilation that Rust does. It downloads all the cargo crates which are involved in this solution and then compiles them as well. So it takes a few minutes, but once it is done, because the Rust compilation uses caching as well, so the next time it won't do that. So it will be much faster from the second time onwards. So what it provides here on the solution is basically a bunch of, you can say, sample code as well. So along with this particular code, or you can say code base in itself, what you get here is a bunch of scripts which help you compile it for the Gautam environment as well. So just like you saw in the previous presentation, Sean was presenting, that the runtime in itself uses Gautam environment, and the other cross-cutting components, consensus like the networking and the other components use the native environment. So in this particular solution, we have scripts to compile it to the Gautam environment as well. We have the regular cargo and common and log, which are required by all Rust projects for dependencies, and it also comes with an initialization script which sets up the environment for you in the beginning. What it also has is basically a bunch of files which provide the groundwork for bringing together all the cross-cutting components and helping you run this node standalone. And finally, what we have, the most important part is from the runtime development is the runtime directory itself, where the business logic lives for your particular blockchain. So here inside this particular library, we build our own modules. Like also rephrasing from the previous presentation, the runtime is divided into modules. So this is particularly the place where you will be putting in your modules to, and then they get compiled into the produce the full runtime. So let's basically look, if you look at this particular project, what it provides you is a complete end-to-end setup to build your own runtime on Substrate. You do not have to worry about pulling in all the dependencies. You do not have to worry about basically how to compile them for Gautam and how to compile them for the native environment, because we have provided those scripts as well. So all you need to do is run this script, Substrate node new, and then you are already on your way to build your runtime. And that's a very, very strong tooling component from the developer's perspective, because it saves a lot of time for basically initially getting started and setting the environment. So let me go back to the slides, and the next script that we have here is the Substrate module view. So what we saw there in the solution was that we could create different modules to produce the entire runtime. The second script is basically giving you to create a new module in that particular folder structure. What it provides also is a simple template for how a module looks like, where what kind of functions reside. So let's take a look at this particular script as well. So if I'm currently in my folder, the demo folder itself, as you can see. Let me also zoom in into this, the terminal window as well, so that it's a little more easy to see. And how do I do that? Well, let's just leave it like that. So the second script that I'm showing here is the Substrate module view script, which is going to create a new module in my folder structure. So what the output of this script will be a new file added to my solution, which will be a new module in this particular runtime. So let's call it module 2, something like that. The author name, again, as I said, is optional, so I'll just call this, and it is basically going to just, maybe I'm not connected to the Wi-Fi, so it's taking a little bit of time, and I'm not sure why it got disconnected. Yeah, it got, so it created a module in my folder structure. Yeah. So this is the new module that got created. It should have the code as well, but because of the Wi-Fi, it did not download that particular code. Let me try that again. Somehow the Wi-Fi is not connecting on this side of the room. But what it provides, this particular script, is a proper setup of a module where you can see how different functions are basically put together. What I have done here is, for simplicity, I have added a few functions which I will go through in a later section of my talk, showing how this works. So let's take a quick review of what we have seen so far. So we have what the folder structure or the code base that we have seen. We are calling it Substrate node template. It basically provides a working Substrate node along with a few SRML modules, the Substrate runtime module library, which Sean was showing in his presentation. It includes some of those modules from the module library as examples, and also for some basic needs. For example, the balances module is used for paying the fees on the transactions that we are doing on this runtime. It also shows basically some of the user scenarios on how we are using these modules in our runtime, and then finally we can also include and extend these modules using our own custom modules. So that is what Substrate node template provides. The Wi-Fi is back on my machine, so I will quickly try to create a new module again, and this time it should work. So yeah, so this is what you get when you create a new module from the script. Basically, it gives you a full template of how a runtime module looks like. It declares some storage variables for you, it declares some dispatchable functions, it gives you some events, one event, and then it shows you how to also test your module. So the first script shows you how to build a full node with a runtime. The second script shows you how to build a module in itself. So this can be a very, very good starting point when you are first time user for Substrate, getting started with it. It gives you a good jump start on these concepts. And once we are basically into these steps, once we have installed the node on our machine, once you have created a module for a runtime, what next comes is how do you implement this module for your particular use case? What are the components of a runtime module? And let's look at them one by one. So before going into the individual components, let me quickly talk about what is the skeleton or the structure of a module in Substrate. So we use some dependencies, like in any software programming language or framework, we have some dependencies, some cross-cutting framework components which we want to use. So in Substrate as well, the runtime modules use some of the framework components which are provided by the Substrate framework itself. These are macros primarily for basically meta programming on Rust. Then we have a special trait inside this, and these are some of the Rust specific terms that I'm using here because, as you know, Substrate is built in Rust. So please bear with me if you are not very well with, or you do not have any specialized Rust knowledge. So the second most important component is the module trait itself. So it basically tells what is our module dependent upon, what are the types it is defining, the type definitions inside this particular module. Then we have three primary components of a particular module. Are basically you can say the main things, like in any particular software programming or framework. When we build software, what do we have? We have simply a bunch of data structures. We have some behavior by which these data structures can interact with each other, and finally we have a way of telling the user what has happened inside the runtime. So exactly that is what we are looking at here as well. Our data structures are defined, or the storage variables are defined in the declare storage macro. This is a Rust macro. Basically, we declare our storage using this, the module storage. And this is exactly where when we were looking at Sean's code. When he changed some of the values over there, he was actually doing that in the declare storage macro. Some of them, when we were adding a field for speed, that was being done through the declare storage macro. Then the second important thing that we have is how we communicate what's happening on the blockchain is through events. Like we saw an event happening when the upgrade happened in the last presentation. We can have our own custom events in Substrate, and that is where the declare event macro comes into the picture. It allows us to declare events for our runtime. And finally, how do we use our module from the outside world? How do these when a user or an application calls our runtime, how do they get executed? That is where the declare module macro comes into the picture. It allows us to basically create or build dispatchable calls for our runtime module, and dispatchable calls are basically special type of functions which are when executed, they are included in the block basically. So those are our dispatchable functions, and the declare module macro allows us to declare those functions. Finally, the last part of the module is the declaration of non-dispatchable functions. For example, a lot of times we want to declare functions in our module which are utilities, which are to be called by other modules but not by the outside world, and which are basically just supporting the dispatchable functions and doing something just for code restructuring and refactoring purposes. So in that scenarios, we use the implementation block of the module, which allows us to do non-dispatchable functions as well. So this is basically how a module looks like in Substrate. These are the primary, you can say, components of a particular module. And let's look at these components one by one, how they are important and how they are basically, how they look like. So before that, let's talk a little bit about macros, what they are, and I mean, if you are not familiar with the Rust side of things, this can be a little bit of challenging concept to, you can say, look into, because I faced a lot of challenges in the beginning when I was looking into Rust. So macros are basically tools for meta-programming. They allow you to create code from code. So a lot of times this helps because Substrate is a framework which requires particular types. It requires, it expects your module to have specific types so that they can be inferred and executed at runtime. Now, all of those types, you don't want to worry about what is that type, what it should have, what it shouldn't have. The macros allow you to do that in a much more easier way. They do have their specific syntax, so we have to look into that, and we are working on documentation and basically making sure that the syntax and how the usage of macros are very well defined and explained, and we are already making progress in that side. And finally, in itself, what macros do is when the Substrate code compiles, they create specific types for the runtime, and when the runtime basically is executed, then these types are particularly called. So what we are doing here is taking a shorthand and defining the whole type system for Substrate by using macros. So this is basically, this was more like, till this point, this was more like an overview of what a module looks like, what are macros, and where they are being used inside Substrate. Now let's look at some of the best practices or individual components on how you will be defining your module. So The first thing that you will be looking at when you are defining a module is whether what should be the storage in your module, whether if you are basically creating an entire app solution, should something live on chain or not? Should something be basically is something needs to be mutable, or it can live off chain just like metadata? You have to basically come up with those answers. And this is very important because in Substrate particularly we do not have the gas metering in the runtime side of things. So we do have gas metering in the smart contract module and other you can say dApps built on top of those, but we do not have the gas metering or you can say calculation or measurement of usage on the runtime level. It is completely free for use, and that is where you have to make sure that the storage that we are defining, we are very cognizant about the fact on what is going on chain, what is not going on chain. If something is going on chain, how simple and easily representable it can be. Because if you have complex data structures, then you will be having complex algorithms to process those data structures, which in itself will basically result in more usage of the infrastructure and more usage of the resources on your particular node. And because the user is not directly paying anything for these usage, they can easily become an attack vector. So you have to make sure that the storage that when you are defining on your runtime is optimized for these kind of scenarios. So we looked at how declare storage. We spoke about the declare storage macro 2 slides before, and now this is how it looks like. Basically, we declare some of the storage values like this. So, for example, this is a simple storage value where we are saying that it is a U32 kind of unsigned 32-bit integer value, and we have defined a default getter as well here, which is simply going to get us the value of this particular field at runtime. So this is how the macros also help us, because